Hi everyone! These days, you probably hear a lot about AI, along with a flood of buzzwords. If it all feels a bit overwhelming, you are definitely not alone. As a data scientist myself, I feel the same. So in this video, we are going to take a journey together to build the mental model that makes all of this a little clearer. I called this mental model the AI tree. You will see as we go why I give it this name, how it built more than AI, and how it continues to evolve. One small note, when I say more than AI, I'm mainly referring to the era after ChatGPT. When I feel overwhelmed, my personal approach is to go back to the foundation, to the roots. So, what are the roots of modern AI? Take a couple of seconds to think about it yourself. Okay, the first root. The first root is the algorithm, the model itself. I'm not expecting you to recognize his face, but if you do, I'm genuinely happy because great scientists deserve more public attention. This is Geoffrey Hinton, the godfather of AI. He is a pioneering computer scientist who spent decades researching artificial neural networks. Artificial neural networks, as the name suggests, must be inspired by our brain's neural networks. We all know how powerful our brains are. That's where our intelligence comes from. Let's zoom in on a real neuron in the brain. It has three parts: dendrites, the input wires that receive signals from other neurons; the cell body, which integrates those signals and decides whether they are strong enough; and the axon, the output wire that sends the signal forward to other neurons. The human brain contains about 86 billion neurons, and each neuron can connect to thousands of others, forming trillions of connections. This vast network is what enables perception, memory, reasoning, and even consciousness. The artificial neuron tries to mimic this structure. Each neuron takes some input signals. Each has different importance or weights. Some are stronger, some are weaker. With this input information, the neuron gets activated and generates the output. The output can then be the input of other neurons. If we abstract this idea, we get a very simple artificial neural network. Each node represents a neuron. There are input nodes and output nodes that form the input layer and output layer. The neurons in between form the hidden layer. This basic structure is simple. So how do we make it powerful enough to capture more complex patterns and relationships in data? We stack more hidden layers. Then the neural network gets deep. That's the deep neural network. Training such a deep neural network is deep learning. Hinton received the Turing Award in 2018 for his contributions to artificial neural networks. No surprise. He somehow received the Nobel Prize in Physics 2024 for the same contribution. Let's move on to the second root, computational power. As neural networks become deeper and more complex, you need more powerful machines to run them. You might recognize this face now. Jensen Huang, the co-founder and CEO of NVIDIA since 1993. NVIDIA is best known for producing GPUs. But what exactly a GPU? And why do GPUs drive AI innovation? GPU stands for Graphics Processing Unit. Originally, GPUs were built for video games. Now, let's compare that with something you already know, the CPU, the Central Processing Unit. You can think of the CPU as a general manager. It can handle almost any type of tasks, but it usually works step by step, processing tasks in sequence. This is great for complex logic and decision making, but not always efficient when you need to perform millions of small calculations. Image processing and later deep learning doesn't care much about doing things in order. What matters is doing a massive number of calculations at the same time. This is where GPUs shine. Well, a CPU might have dozens of cores, maybe 64 or 128 at the most. A GPU can have thousands of tiny cores. Each core is simple, but together they can process huge amounts of data in parallel. To make GPUs useful beyond gaming, CUDA was introduced in 2006. CUDA is a software layer on top of the GPU hardware. It acts like a bridge, making the GPU's raw power accessible for not just graphics, but also for general-purpose computing. That moment opened the door from gaming and 3D graphics into a new era, accelerated computing. More importantly, it removed one of the biggest bottlenecks in training deep neural nets. GPUs were no longer just gaming chips. They became the engines of the deep learning revolution. Just like oil powered the industrial age, GPUs power the AI age. Whoever has access to GPUs has an edge in AI. It's no surprise that companies like OpenAI, Google, Meta, Tesla are competing to secure as many GPUs as possible. And this isn't just a company-level competition. It's also happening at the national level. The US and China both see AI as a path to global leadership, which means a race for GPUs. That's why the US now restricts exports of advanced chips to China. Taiwan plays a critical role here. Almost all cutting-edge GPUs are manufactured by TSMC, Taiwan Semiconductor Manufacturing Company. This makes Taiwan's semiconductor industry a critical part of the global AI ecosystem and a key factor in today's geopolitics. Now, the third root, data. Without data, what can a model learn from? And it's not just about having data, the quality matters too. As we often say, garbage in, garbage out. This brings us to Fei-Fei Li, often called the godmother of AI. She is a professor at Stanford University and she led the creation of ImageNet. ImageNet is a massive labeled image dataset. Before ImageNet, researchers simply didn't have enough labeled data to train powerful deep learning models. Models could recognize very limited things, like handwritten digits or simple faces, but not the complexity of the real world. ImageNet changed that. It contains over 14 million images, each hand-labeled across more than 20,000 categories. You could say ImageNet gave AI eyes. It allowed machines for the first time to learn how to see the world at scale, and it proved something fundamental. Data scale matters. The more high-quality data you have, the better your model can learn. In 2010, Fei-Fei Li launched the ImageNet Challenge, an annual competition to measure how well AI systems could recognize objects. For the next 2 years, the results were not particularly exciting. Until 2012. That's when AlexNet appeared. AlexNet didn't just improve performance, it shifted the entire direction of AI. For the first time, all these three roots came together: powerful models, large-scale data, and massive computational power. The result was dramatic. On the ImageNet Challenge leaderboard, AlexNet reduced the error rate by 10 percentage points ahead of the second-best model. That moment ignited the modern AI revolution. It showed just how powerful things can be when these three forces come together. Here is the original AlexNet paper. Don't panic. I'm not going to ask you to read it. It's just kind of cool to see what such a revolutionary idea looked like at the beginning. AlexNet is named after the first author, Alex Krzyzewski. You see, they trained deep convolutional neural networks on the ImageNet dataset using GPUs. Could you recognize other names? Geoffrey Hinton, the godfather of AI. Alex and Ilya were his students at the University of Toronto. Ilya Sutskever co-founded OpenAI 3 years after the AlexNet paper, together with Sam Altman, Elon Musk, and many others. He was the former chief scientist and played a key role in the development of ChatGPT. He was already well known in academia, but the general public may have first heard his name in 2023 during the leadership crisis at OpenAI. After Sam Altman was reinstated, Sutskever stepped down from the board. By the way, in an interview after winning the Nobel Prize in Physics, Geoffrey Hinton expressed support for Sutskever's decision to fire Altman, emphasizing concerns about AI safety. If you are interested in the stories behind ImageNet and AlexNet, I highly recommend Fei-Fei Li's memoir, The Words I See. It beautifully combines a personal journey with a pivotal chapter in AI history. As a Chinese-born girl, I've always admired Fei-Fei Li. When I was young, I also dreamed of becoming a scientist one day. Turns out, I just needed a corporate job to get scientist in my title. So what happened after AlexNet? The building blocks of neural networks didn't fundamentally change. Neurons, activation, connections, layers. Researchers are playing with that like playing Lego. They try to architect the neural networks to solve different problems like image recognition, language translation, and so on. One of the architecture is convolutional neural network, CNN, for images. AlexNet is one example of that. Another architecture is recurrent neural network, RNN, for sequential data, which is used in natural language processing and time series. And then came the real breakthrough. In 2017, the transformer was introduced. That's the foundation architecture behind today's generative AI. Again, I'm going to just show you the paper, but don't panic. The paper is called Attention is All You Need. In the next video, I will explain in plain English what attention means here and how the transformer works intuitively. No math, I promise. And for those who want to go deeper, I'll also make a separate video where we walk through the paper together. Now, let's summarize some key concepts here. You can think of these concepts like Russian nesting dolls. The term artificial intelligence was first coined in 1956 by John McCarthy at the Dartmouth Conference. The event often considered the birth of AI as a field. So it's actually not something new, and it remains the broadest concept. Inside AI, we have ML, machine learning. It simply means training a machine to learn from data. Within that, artificial neural networks are one family of models. Deep learning, as we've already talked about, is to train neural networks with many layers. On top of that, we now have generative AI, Gen AI, models that can create content, text, images, music, video, or code. And within that, large language models, or LLMs, specialized in generating text. Examples include ChatGPT, Cloud, and DeepSeek. So when people talk about AI today, they are often referring to different layers of this structure. And without this mental model, it's easy to feel confused. Now we have our AI tree. 3 roots: model, data, and compute. Came together in 2012 with AlexNet, making the beginning of deep learning revolution. One of the strongest branches to emerge is the transformer, introduced in 2017, the foundation of today's generative AI. And the tools we use today, ChatGPT, Cloud, are the fruits of this tree. Thank you for watching. I'll see you in the next video.